number 2 on page 102. We've got the cat. The cat is going off of the table. When the mouse steps out of the way, the table's 1 meter high. And that cat lands on its feet, of course, 2.2 meters out from the surface of the table. So we have this motion, okay? What we're being asked for is the cat's speed when it went off the end of the table. We know that there was some initial velocity. If there was no initial velocity, it just would have gone straight down, right? Okay. So, x-axis, y-axis. Always break up your variables. Are those visible on the screen?
Yes. Yes.
Okay. All right. So on the x-axis, we have some initial velocity. We'll look at initial velocity on the y also. Well, the Vix is going to be equal to what part of that initial velocity?
All of it.
All of it! There is no initial y velocity. So we'll mark that, and that's what we'd like to know, because we want Vi. Okay?
Are most of the problems going to be looking for Vi?
No. No. Okay, so maybe I should have done number 3. Actually, the ones in the book are mostly Vi. On your worksheet, they're different. Okay, so let's look at acceleration. Acceleration on the x, acceleration on the y. What's our acceleration on the x?
0.
0. There is no acceleration on the x. What's our acceleration on the y? Negative 9.81 meters per second squared. Okay. We have displacement to consider. Delta x, delta y. What's our displacement on the x? 2.2 meters. Displacement on the y, negative 1.0 meters. Okay, and then what will be our bridge between our two axes? Time. You could make up some sort of cheesy song about time as a bridge. You could. Okay, so we know that this initial, since there's no acceleration, initial x velocity is equal to, final x velocity is equal to x velocity. We can create an expression for time. Do it. Go.
All right.
Yeah, but I'm having you walk through it on your own. We're scaffolding. So you do
Will
it.
it always be that?
That's one of the common ones.
Whenever you're looking for time, is that always?
You can put that on your card, yes.
V equals delta x over. What equation are you talking about?
Delta t equals delta x.
I think he's talking about the solve for.
Okay.
Okay, so on the y-axis, we've got acceleration, displacement, time, and initial velocity. Do we have something that ties those together? Sure. We've got our old friend, delta y equals vi delta t plus 1/2 a delta t squared. And where vi is equal to 0, we have that. So we can solve that for t. Square root of 2 delta y over a equals delta t. So since delta t is, there's a delta t value for every point in that motion, and it's going to be equal for some points in that motion, we can set these two equal to one another. Solving for v sub x, we get And I think this is probably the equation he's talking about putting on his card.
Yeah.
That's fine. Yeah, and you can put that on your card. Again, it depends on how your brain works. For me, I need to see where it comes from, and that helps me understand it. But you can put it on your card as a shortcut and also as a double check. Okay, go ahead and solve for v sub x. What'd you get? What'd you get? What'd you get? Got numbers yet? Got numbers yet? Pardon?
What?
Okay, after we come back from break. Is there a way to pause the video without stopping it?